Hi students, welcome to Math for You. Today we are going to discuss about some questions from number system and polynomials. Let's get started. So here you can see the first question, y is equal to root 5 minus 2. If y is equal to root 5 minus 2, then find the value of y minus 1 by y the whole raised to 3. So it is given y is equal to root 5 minus 2. So for finding out this one, we need 1 by y also, right? So 1 by y is equal to, can I write this as 1 by root 5 minus 2? Yes. So in order to eliminate this root here, what we usually do, we have to do the rationalization of the denominator, right? So how can we do the rationalization? We will be multiplying the given number with the numerator and denominator with what? The conjugate of the denominator. That means what is the conjugate of root 5 minus 2? That is root 5 plus 2. Root 5 plus 2 by root 5 plus 2, right? So how you will multiply these two? You have to multiply the numerators, right? So 1 into root 5 plus 2 is root 5 plus 2. When you multiply the denominators, you can see that root 5 minus 2 multiplied with root 5 plus 2. Can I write this in of the form a minus b multiplied with a plus b? What is a minus b into a plus b? Or a plus b into a minus b? Can I write it as a square minus b square? So in this case, what is a? A is root 5, and what is b here? B is 2. So according to the identity, we have to write a square minus b square, right? So a is a root 5 square minus b is 2, so 2 square. So you can see here root 5 plus 2 divided by root 5 the whole square. What is root of a number when it is squared? You will get the number itself, right? So can I write here as 5 minus 2 square? You all know that is 4. So the denominator comes as 1 now. So 1 by y is equal to what you got, root 5 plus 2. Now what we have to find out, y minus 1 by y the whole raised to 3. So y minus 1 by y the whole raised to 3, can we write it as y, as we already know root 5 minus 2, and that is equal to root 5 minus 2 minus 1 by y. What you got? 1 by y is root 5 plus 2. So we are writing it inside the bracket as 1 by y. We have here root 5 plus 2. Okay, this whole raised to 3. And first we will solve inside the bracket, right? So root 5 minus 2, minus into root 5 is minus root 5, minus into positive 2 is minus 2 the whole raised to 3. Can I cancel positive root 5 and negative root 5? Yes. So after cancelling, you will get inside the bracket as minus 2 the whole raised to 3. That means minus 4 raised to 3. What is the answer for this one? Minus 4 raised to 3. What is minus 4 raised to 3? Negative number raised to an odd number will be negative. That you know, right? So negative raised to any odd number, negative number raised to odd number, you will get negative only, the sign. Okay. So here you have negative, then here 4 into 4 is 16. 16 fours are 64. Can I write it as negative 64 as the answer? Is that clear? So whenever you are getting like this, first you have to find, you have y, you have to find out 1 by y rationalized form. Then whatever inside the bracket you have to solve first, then take the cube of it. Clear? So let's move on with the next question. So let's see the next question, that is if xy plus yz plus zx is equal to 0, find the value of 1 by x square minus yz plus 1 by y square minus zx plus 1 by z square minus xy. So how can we do this one? What is given first? You have to check. Okay, it is given that xy plus yz plus zx is equal to 0. This is a given thing in this question, right? So can we find out anything from that? So we need to find out the value of this one. We need what is yz, what is zx, what is xy, etc. Right? So I'm take down what is given first. Okay, so it is given xy plus yz plus zx is equal to 0. Can I find out the value of minus yz minus zx and minus xy from this what is given? Yeah. So let's see. I'm taking this yz to the right hand side. So what is left over in the left hand side? That is xy plus zx is left over. And if I'm taking this yz along to the right hand side, this is positive. That will become what? Negative yz. Now we are going to find out minus zx. So same equation you can find out minus zx. What will be minus zx? I'm just writing the equation and what is given same again is equal to 0, right? So now we need zx. So plus zx I'm taking to the right hand side of this equation, and what you will get there, the left hand side we have xy plus yz, and this will be equal to minus zx. So you got that value. So similarly, can we write this minus xy, value of minus xy as directly? Yes, you have to just consider this xy we are keeping on the right hand side and the rest will be on the left hand side. So this is equal to yz plus zx, right? So now you got all the values of these three what is required. This one you got, this as well as this one. So what we have to do next? Next we have to substitute these values in the given this one, 1 by x square minus yz plus 1 by y square minus zx plus 1 by z square minus xy. So instead of this minus yz, minus zx and minus xy, we are going to put these three values with what we have obtained now. So let's see how it will be once we are substituting that. Okay, so let's get started. 1 by x square minus yz. Minus yz is what we got it as what? Plus xy plus zx from here, right? And next plus 1 by y square. What do you have here? Instead of minus zx we have plus xy plus yz, right? So one more term we have to do, right? So next term is plus 1 by z square minus xy. Instead of minus xy you have this one, that is plus yz plus zx. So now we are going to find out the value of this one, right? So in this one, you can see the denominator of the first term. What is common over here? Can I take x as common from this as like this? 1 by x into, so if I took 1x, there is 1x left over there, x plus y plus z. So plus you have to check for the next. You can see y is common everywhere. So I took one y out and y plus x plus z. Next one, you can see that z is common over everywhere. So z plus z I have taken out, one z inside plus y plus x. So if you are checking inside the bracket of the denominator, you can see that everywhere it is x plus y plus z, right? I'm going to take this x plus y plus z as a common out of the bracket. So I'm taking 1 by x plus y plus z as a common for all these three terms. So what will be inside the bracket? Inside the bracket there will be 1 by x plus 1 by y plus 1 by z, right? 1 by x plus 1 by y plus 1 by z will be there. So once you got this one, how can we do the rest? Can we take the LCM of this one inside the bracket? Yeah, so let's do that one. We are going to take the LCM of this one, okay? So once we are taking the LCM of this one, you will be clear with that how can we do the rest. So the whatever outside the bracket, it will be there, x plus y plus z, okay? Inside the bracket, it will be, what will be the LCM of this one? 1 by x plus 1 by y plus 1 by z. The LCM will be xyz, right? This one is xyz. So xyz, okay, I have taken the LCM for the first one, 1 by x into xyz by xyz. What you will get? Yz plus, yes, here also what you will get? Zx plus yx. So once you attained this one, you have to check the numerator here. What is this value given in the question? The numerator of this one, what is given in the question? This much is equal to 0 is given in the question, right? If xy plus yz plus zx is equal to 0, this is what the question says, right? This part. So what we can do is we can put that value as 0. So once you put the value as 0, what will be the answer? This is equal to 1 by x plus y plus z. Inside the bracket you will get 0 by x, y, z. You know that 0 is multiplied with any number, the answer will be equal to 0. So the value of this one, once you have completed, what you will get? You will get it as 0. Exactly. Third question, you can see that prove that p square minus q square the whole raised to 3 plus q square minus r square the whole raised to 3 plus r square minus p square the whole raised to 3 is equal to 3 into p plus q multiplied with q plus r multiplied with r plus p, again multiplied with p minus q, q minus r, and r minus p. When you see the question, you will feel that it is very difficult, but it's very simple for you to do. So let's see how can we do this question. Okay. So each term inside the bracket, first we are taking out the LHS and we will reach out the RHS. That is how prove that questions will be, right? We will take, you know what is LHS and RHS, right? This is LHS and this is RHS. Okay. Left hand side and right hand side of the given equation. So let's take the LHS first. We are taking the LHS first. What is the LHS given? P square minus q square the whole cube plus q square minus r square the whole cube plus r square minus p square the whole cube. This is the LHS what we are going to start with. So can you imagine any of the identity which you have learned is related to this? Do you remember the last identity you have learned in the chapter polynomials? That is x cube plus y cube plus z cube minus 3xyz is equal to, what is that? X plus y plus z multiplied with x square plus y square plus z square minus xy minus yz minus zx. I hope you all remember. So in that we have learned one more thing. If x plus y plus z is equal to 0, what we have learned? X cube plus y cube plus z cube will be equal to, do you remember? This will be equal to, yes, 3xyz. This we got from the 8th identity, as I told we have learned in the chapter polynomials. Clear? So let's apply this over here, and for this one we are going to find out this x cube plus y cube plus z cube. That means what we are going to do is we are first putting this one inside the bracket as each variables. Okay, so first one I'm going to put this as a, this as b, and this as c. That means it is reduced to the form a cube plus b cube plus c cube. This is the one what we have to find out. For that, let me check first whether these are all equal to add up to 0. Let me check. That means I'm going to check what is a plus b plus c now. So a, as we know, a is p square minus q square plus b is q square minus r square plus c is r square minus p square. So if this is equal to 0, we can say that this will be equal to 3abc, right? If I told if a plus b plus c is equal to 0, then only this will work, right? So let's see whether this will be working for our question. Okay, so now you can see that p square minus p square is there, positive and negative all got cancel, and we got this is equal to 0. That means x plus y plus z is equal to 0, as from our identity we learned that x cube plus y cube plus z cube is equal to what? 3xyz. So now we can apply that over here, and you can see that a cube plus b cube plus z cube is equal to 3abc. So let's start doing that. What is a over here? A is p square minus q square. So now we are going to check what is a. A is p square minus q square the whole cube plus b is q square minus r square the whole cube plus c is r square minus p square the whole cube. This is equal to 3 into a, b, c. 3 multiplied with a, p square minus q square, b is q square minus r square, and c is r square minus p square, right? So now we are going to apply identity over here for each one. How can we do this one? P square minus q square. What is a square minus b square? A plus b into a minus b. Same we can apply over here. P plus q into p minus q. Then the for q square minus r square, q plus r into q minus r. Again r square minus p square, r plus p into r minus p. So what exactly we have to find out? Let's go back to our question now. So you can see here in our question what is asked to find out here. 3 multiplied with p plus q, q plus r plus p. Let's check whether all these all these are in this, what we have found out in this. Okay, so p plus q is there, then q plus r is there, r plus p, yes, r plus p, then p minus q is there, q minus r is there, r minus p is there. So what we need to do is now just we have to rearrange and write it in a order. So this is our LHS, that is equal to now 3 into p plus q, then q plus r multiplied with r plus p, then again p minus q, and q minus r, then r minus p. So now we have arrived at the answer LHS is equal to RHS, and thus proved. Is that clear? We have done the 3 questions, which is very good questions from these 2 chapters. So try it and feel free to contact for your doubts. Thank you.